Hey guys, my name is William and I'll be your speaker today. Welcome back to another lecture on our Geometry and Proof course. Today we'll be talking about Introduction to Proofs and how proofs are actually implemented in geometry with proof. Alright, let's get started. So first of all, proofs require reasoning. So first of all, to prove a statement, you need some sort of reasoning. If you haven't watched Adam's video on logic, conditionals, and deductive reasoning, please be sure to watch it right here. If you understand the concepts of conditionals and logic, you'll be able to do most of the proofs that I'll be presenting today. Proofs also require the use of theorems, postulates, and properties of equality and congruence. Our next topic is the concept of a two-column proof. In the Geometry with Proof course, we use two columns to present a logical argument to successfully prove a statement. The two columns contain statements and reasons. Statements are listed out in order and eventually lead up to the final statement that you want to prove. Reasons, on the other hand, explain the statements. We'll be getting into this a bit later, and I'll show you guys a couple of practice problems to help you guys have a better understanding of two-column proofs. So let's first start off by reviewing properties of equality and introducing properties of congruence. So the four basic mathematical operations are also properties of equality. As seen in this table, if the two values, in this case variables a and b, are equal, then all four of these properties, addition, subtraction, multiplication, and division, all apply. So these four properties of equality should be pretty intuitive. Now let's move on to common properties of equality and congruence. These are the reflexive, symmetric, transitive, and substitution properties of equality and congruence. Again, if two values, in this case variables a and b, are equal, these properties of equality and congruence apply. These properties are pretty common in proofs, and they are usually properties of congruence. Now, if you take a look at these three properties, the reflexive, the transitive, and the symmetric, you can actually see that these properties prove two objects or more congruent. Now, these statements are called congruent statements. These statements must be used in proofs to prove that two objects are congruent to each other. Now, do not forget this step in a two-column proof. You have to prove that these items are congruent in order to move on to a next step. Most proofs are actually incorrect and could be incomplete without these properties. Okay, let's move on to a practice problem. Take a look at these statements and try to fill in the blanks. Remember to use the properties of equality and congruence that we just went over. Yeah, you guys have 10 seconds, time starts now.
Like the cool blue light. Like the cool blue light.
Okay, time has now elapsed. Let's reveal the answers. So here are the answers to these problems. As you probably can tell, all three problems use the transitive property of congruence. This is the property where if A equals B and B equals C, then A would equal to C as well. Except this time you're just replacing the variables for different angles and replacing the sign of equality for the sign of congruence. If the differences between equality and congruence kind of mess things up for you, just remember that equality is the equal sign, but congruence is just the equal sign with a wiggly line above it. So for example, these angles have equal degree measure, therefore they must be congruent. Okay, let's move on. Here is a sample proof that I want you guys to practice. Remember to implement the properties, postulates, and theorems that we learned in previous lessons, and remember to use a two-column proof with statements and reasons. Okay, please take 30 seconds to write out a basic two-column proof. Time starts now. Good luck.
Sit down. Sit down. Sit down.
Okay, time has now elapsed. Let's move on to the solution. So first of all, in all two-column proofs, we have to write out the given statement. So in this case, the given statement is segment AB is congruent to segment CD. So therefore we write that out as our first statement and our reason would just be given. Next up is the definition of congruence. If segments AB and CD are congruent, that means they have equal length, so AB must equal to CD. Now, the third part would be the reflexive property of equality, to prove that BC equals BC. Well, why do we actually need to prove this? Well, since we're trying to prove that AC is congruent to BD, we have to use the combination of different line segments and their different lengths to prove that AC and BD have the same length. So moving on to the last three parts of this solution. Since we already proved that BC equals BC with the reflexive property of equality, we can just use the addition property of equality and prove that AB plus BC equals BC plus CD. Therefore, that would be our fourth statement and our fourth reason. Last but not least, use the segment addition postulate to combine the two segments. So AB and BC would just be combined as segment AC, while BC and CD would just be combined as BD. Therefore, our fifth statement is that AC equals BD, and the reason would just be the segment addition postulate. And last but not least, the last step would just be segment AC is congruent to segment BD, and that would just be the definition of congruence. And there you have it. Congrats on finishing your first two column proof. So these proofs can seem daunting and intimidating at times, but please be sure to write out these steps logically, and make sure you list out each step so you know what comes before it and what comes after it. Eventually, you will reach the final statement and you can just prove that statement with different reasons. Now let's move on to another concept, proving angles congruent. Let's first start off by new theorems on vertical and right angles. So the vertical angles theorem basically states that vertical angles are congruent. So in this case, angles 1 and 3 and angles 2 and 4 are congruent pairs. The other theorem states that all right angles are congruent, which is intuitive because they all have the same degree measure of 90. And in this case, if all angles on the diagram are right, angles 1, 2, 3, and 4 would be congruent because all right angles are congruent. Okay, let's move on to theorems on complements and supplements. So just for review, complementary angles are two angles whose degree measures add up to 90 degrees, and supplementary angles, on the other hand, are two angles whose degree measures add up to 180 degrees. If two angles are complements or supplements of the same angle or congruent angles, those two angles must be congruent and have the same degree measure. Furthermore, if two angles are congruent and supplementary, then both of these angles must be right angles. These examples can all be seen on the example on the right. Furthermore, angles A, B, and C are right angles because they are supplements of each other and that they are congruent. Okay, let's move on to a practice proof. Take a look at this problem and make sure you understand the given and the statement that you're trying to prove. Also, use the diagram to your benefit. They will help and come in handy quite a bit. Please take 30 seconds to derive a plan of attack for this proof and try to solve it with a two-column proof. 30 seconds, start now. 30, 29, 27. 30 seconds, start now. Okay, time has now elapsed. Let's take a look at the hints for this problem. So again, make sure you use a two-column proof and implement the properties, postulates, and theorems seen in all of our previous lectures. Here is the solution to the proof. I will walk you guys through it. Let's take a look. We're given that the measure of angles BOF and FOD are equal to each other. We're supposed to prove that the measure of angle AOE is equal to 2 times the measure of angle BOF. Yeah, let's get straight into it. So first of all, as always, write out the given. The measure of angle BOF is equal to the measure of angle BOD. Our next step would be the angle addition postulate. Because angles BOF and FOD are next to each other, make sure to add these two angles up so that you can form angle BOD. By doing this, you can also implement the substitution property, because Since BOF is equal to FOD, you can substitute FOD for BOF and you'll get 2BOF is equal to BOD. Next up, use the vertical angles theorem to prove that angle AOE has the equal measure. Next, use the vertical angles theorem to prove that angle AOE has equal measure as angle BOD. Last but not least, in step 7, use the substitution property of equality and substitute BOD for 2 times angle BOF to prove that angle AOE, the measure of angle AOE, is equal to the measure of angle BOF times 2. Yeah, and that's how you solve the proof for angles, man. Just be sure to use theorems, postulates, and properties to your own advantage in these proofs. And again, although these proofs can be tedious, once you list out each logical step, they will become a lot easier. Okay, let's move on to the summary for today's lecture. So first of all, we explored the concept of proofs, and we also explained how we can use 2-column proofs to actually prove statements. Next, we explained properties of congruence and also reviewed some properties of equality. Please remember that these properties of equality quite often come in handy in proofs, and please be sure to use them, as if you don't use them, you might get points off. Last but not least, we also talked about how we can prove angles congruent, and I also explained their relative theorems, postulates, and properties. Yeah, and that's about it for the video. Thank you so much for coming to today's lecture, and as always, we hope to see you in future videos.